Okay, for today's notes, we're going to start talking about pyramids and comparing the differences between a pyramid and what we just got through studying with the prisms. So nets are the shapes unfolded. Looking at our first example, and you can see the bases have been shaded for you. The shape that we're looking at, folded along the dashed lines, is a triangular prism. And then the new net next to it to the right, if you fold it against the dashed lines, we are looking at what we call a square pyramid. And its pyramids get their names from their bases. Okay, down below it, we are looking at identifying the parts of a net of a pyramid. The most obvious one is the base. And then we've got what we call the lateral face. Which just means the sides of the shape, not including the base. Then you have, and you want to be familiar with this term, we call the lateral edge. And then this one, I'd like you to star this one in your notes because this one's going to be important. You're going to see this through some quizzes and assignments. This is what we call the slant height. And the name kind of sounds with what it goes with. It is the height, it's not the height of the pyramid, it is the height of the lateral face, which again we'll come back and work with that later. To the right, the closed square pyramid. The top part, I want you to note it as vertex, but I'd also like you to put underneath it apex. And that is the term that I've used all my years that I've taught geometry and through my school years of geometry. Okay, the closed shape, this part right here is your slant height. And then going from the center of the base through the vertex or the apex is the height of the pyramid. Again, it's got to go through the vertex at the top. Well, the main thing right now is that you can tell the difference with it closed, your slant height to your height. And you cannot see the height of the pyramid on the net. You can see it when it's closed, but you cannot see the height of the pyramid when it is the net. Okay, now we're going to compare and contrast all types of prisms to all types of pyramids. We're not looking at any specific example. Again, what we're filling in the blanks are characteristics of all prisms. So you may even want to add that to your notes if you're not sure. So we're talking about all types of prisms, and we're talking about all types of pyramids. Okay, for prisms, they are named by its base. And remember, there's two of them, so I'm going to put named by its bases. And then for the pyramid, it's named by its base because it's only one. And I'm going to go back and put, because prisms have two bases, that's why I'm putting it with the S. Okay, number of lateral faces equals. So if I'm thinking about a triangular prism and it's closed or open, and the number of lateral faces, that's the sides of it, not the bases. How many lateral faces does a triangular prism have? Well, it has 3. And how did I know that? Because the number of lateral faces equals the number of sides of its base. Sorry, the handwriting's sloppy. Okay, for the pyramid, the number of lateral faces is the same situation. So even if you were to look at this example right here, the number of lateral faces equals the number of sides of the base. Okay, so now we're coming back to the prism on how many bases does a prism have? It has 2. And then how many bases does a pyramid have? It only has 1. Okay, lateral face of a prism. Let's think. Lateral faces, they're all rectangles. And if you did not know that, you can go back and look at the notes that you color-coded before spring break, where we colored the bases in blue and the faces in different colors. Okay, the lateral face of all pyramids is a triangle. And the next question is kind of tricky. The height is, can you see the height on a prism when it's just giving you the net? Yes. So the height is visible. Means you can see it on its net. And then think about it. We just got through talking a while ago in the previous examples. The height is not visible on its net. Okay. And then the last question is there a slant height on a prism? No, because if you go back and look at all the shapes folded closed, there's no slant height. Is there a slant height on a pyramid? Yes, and that's what we're going to start studying in just a moment. Okay, for example 1, determine whether each net will form a period when folded to make a solid. If yes, name it. I'm going to give you about a minute to go ahead and answer all 3 of these, and then I'd like you to come back and continue with the video to see if you are correct. I would like to give you a hint. What I do is put the number of sides inside the base. So this one has 4 sides. And then I go and I number the lateral faces. So hopefully this is a good hint for you to decide if it's a yes or a no. Okay, coming back to this one, hopefully you pushed pause a while ago. If not, go ahead and push pause now to go and answer those before you finish watching the video. For our first example, it is a pyramid because the number of sides to the base matches the number of lateral faces, and they want us to name it. Pyramids are named by their bases, so this is a square pyramid. Letter B, we have a hexagon which has 6 sides, and this example only gives us 5 lateral faces, so no, we cannot make a pyramid from the net. For our next example, it kind of doesn't really matter since they're all the same shapes. I'm going to make this part the base. It has 3 sides, and it has 3 lateral faces, so yes, you can form a pyramid. And the name of this one is obviously a triangular pyramid. I'll abbreviate pyramid for you. Alrighty. Hopefully you have that understood, and then we're going to move on to the next example. Okay, before you check your answers with me for this example, I would like you to push pause and try to go ahead and name all the parts of the pyramid, the vertex, the lateral faces, the lateral edges, and the base edges, and then compare with me to see if you understand it, because it kind of is review from middle school math. The vertex is called point E. We put capital E, but we don't put the word point or put a dot in front of it. So when you name it, you don't just say E, you say point E. The lateral faces are the triangles that, well, they're the triangles because the base is a square. So our lateral faces are going to be triangle, and it doesn't matter the order of the letters, but you do have to have all three. So we've got, I see AEB, I see triangle BEC, I see triangle DEA, and since this is a square-based pyramid, we have 4 lateral faces, so we should have 4 triangles. And then I see the back one, so I see triangle DEC. For our lateral edges, there's going to be 4 since there was 4 faces. And those are line segments, so we have line segment AE, we have BE, we have CE, and again you can put EC if you want, or EB, and then we have DE. For our base edges, to finish this example out, they go along the base. So we have AB, BC, CD, and AD. Hopefully you got all of those right. If not, go ahead and write some questions down so I can answer those when we get a chance. Okay, for this example, I hope we remember Pythagorean's theorem and that you see the right triangle inside the pyramid. This is the height with the dashed line, and then you have the slant height. On our formula charts, it is the lowercase script L, but for right now, I'm just going to put slant height so you can kind of see the difference. Our job is to find the slant height, and what we're going to revisit multiple times is that only for a square-based pyramid, since this part here and the base edge are parallel, and this is going to be called the apothem, since the apothem starts at the center and goes to the midpoint of the base edge, and these two are parallel, we can actually take the 12 and divide it by 2 to get the length of the apothem. And again, it's just for the square-based pyramids. So half of 12 is 6. And since we have a right triangle, if you do recall, we're going to draw the arrow through the right angle box, and it's facing, we called it the hypotenuse at the time, now it's the slant height in the pyramid, but we're going to do the same thing. So using our calculator, since it is not facing a number, we're looking for the slant height. Then in our calculator, we're going to do square root of 6 squared plus 8 squared. And that's going to give us the answer of, in our calculator, 36 plus 64 squared. It's going to give us 10. For those of you that like to write it out, we have 6 squared plus 8 squared, which is 36 plus 64, and that's going to give me 100. Now that's for c squared, that's 2 c's. We don't want 2 c's, we want 1 c. So if we take the square root of 100, then that's going to give us the 10. So our slant height for example 3, letter A, is 10. Okay, looking at this example, it is important that we read all the information that's given before we get started. All they gave us in the picture is the slant height. 29 does represent the slant height. So if the perimeter of the base is 160 units, and we're looking at a square-based pyramid, then we know that each side has to be the same. And since there's 4 sides, 160 divided by 4 is 40. So we know that the base edge is 40. And just like our previous example, we said that since these two, this one and this one, are parallel, we can divide it by 2. So our apothem is going to be 20, and the question is wanting the height of the pyramid, which is this part right here. Well, we all know, we've talked about it many times, that given a right triangle, if we've got 2 of the 3 lengths of a right triangle, then using Pythagorean's theorem we can find the third length. For this example, they're giving us the hypotenuse, aka slant height. So in the calculator, we are not going to add them. We are going to subtract them. Since we are subtracting, the larger number does have to come first. And 29 squared minus 20 squared, and we're taking the square root of that. Give me just a moment. That's going to give us a value of 21 units. All right, we're almost done. The last 2 examples do take more work, so again, I'd like you just to finish watching the video, write in the notes, and then attempt as many problems as you can. If you can at least get to the first step of solving this, that would be great. But let's see how far we can get with this one. So they're telling us, and this is a triangular-based pyramid, so it is different than the first 2 examples. They're telling us that the height is 30. The height will be the dashed lines coming from the center of the base through the vertex. So this part is 30. They want us to find the slant height, which is the hypotenuse, if that's what you want to call it as well. So we're looking for this part. So here we go. The base edge is the entire base edge is 32 square roots of 3. So that's the base edge. From this part to this part is half of the length of the base edge. So if we divide 32 square roots of 3 by 2, we're going to get 16 square roots of 3. Well, let's just take a moment to review the 30, 60, 90 triangle. And it is on the base only for what we're going to be doing. So down here at the bottom, I'm going to outline it in green. And then if you recall, I'm going to bring it up here. The shorter leg of a triangle, let me change that just a moment. The shorter leg is x, the longer leg is x square roots of 3, and the radius is 2x. You won't be worrying about the radius for right now, but the 16 square roots of 3 represents the x square roots of 3. So our x value is 16. So now you know the apothem, which is the bottom part of the right triangle. So what I'm going to do is pull out the right triangle, the one with the orange and the blue, and I'm going to put it over here. We have the height at 30. We have, again, that bottom part down here was 16. So I'm going to bring it over here, and I'm actually going to change the color of the 30 to show you where it was on the original picture. And so our job is to find the slant height. Since we have a right triangle and we're missing the hypotenuse, aka the slant height, we're going to be adding these in the calculator. So 30 squared plus 16 squared, and we take the square root of that, which is really 900 plus 256. Gives us a value of 34 units, which is the length of the slant height. Again, you may have to watch this example more than once to understand all the parts of it, or on the next example, maybe pause it at different points. But you will be using this throughout this unit, so I would take a moment to try to take the things you've learned in Unit 12 and 13 and see how they come together for the examples that we're going to be doing. Okay, last example for these notes, and if you can tell, it's kind of similar to example 3b, where it gives us the perimeter and the slant height. So we've got the slant height, and our job is just to find the height, which is again the dashed line. So if the perimeter of the base is 60 square roots of 3, and this is the part you may get confused on a few times, but since we are talking about a triangle base, how many sides to a triangular base? Okay, so there are 3. So I'm going to take 60 square roots of 3 and divide it by 3. And that's going to give us 20 square roots of 3 for each base edge. So I'm going to come down here. If the entire base edge length is 20 square roots of 3, and after we do this enough times, you're going to automatically know that when you write that number down, what the apothem is going to be, or the length of one of the legs on the right triangle. But if the whole base edge is 20 square roots of 3, then we know from here to here is 10 square roots of 3. Then we know our x value, because this is x square roots of 3 base, because it's the longer part. So from here, from the center to the base edge is 10. I'm going to pull that right triangle out and redraw it so that we can, here's the dash part. Since our job is to find the height, and we know the length across the bottom here is 10, and we know our slant height is 26. Since the arrow is facing a number, then if we're going to just use a calculator, it's going to be slant height minus leg squared, and take the square root of all that. So 26 squared which is 676 minus 100. That leaves us with the square root of 576. And I believe that is giving us a value of 24 units. Okay, really quick recap. Don't forget that your slant height has to be the largest number out of that right triangle. So if you got a number bigger than 26 for this example, then you know you did something wrong. You had to go back and revisit your math. I hope the notes help a little bit. I will be back. Well, I'll be after school tomorrow if you need me for any questions, and then we'll revisit this when I get to class on Tuesday.